All right, class. So this is, I believe, this is the third day of the review, and it's going to focus on graphs. And so, again, here's a few questions: which variables represent domain and range? So remember, domains are your x values, right? So domain, I put D for domain are your x values, and range are your y values. Okay, a lot of kids, they kind of get them mixed. All right, so if you have your axes, right, this is my x and my y, right? Domains are on the x axis, and range are on your y axis. Right, that's how you read that. All right, so just make sure you understand that. So range are all your y values, domains are x values. Okay. All right, let's move on. Now, here you're given 4 graphs, and you're given the linear equation, and you want to know which equation best represents the graph. So here you look at it's a linear, right? And best represents is a keyword, which means represents. Okay. So it just means that is equal to the equation. Now, whenever you have an equation that is not in slope-intercept form, meaning that it must be in this form, y equals mx plus b. Okay. When I say must, I shouldn't use the word must. Transform any equation into this format, and so you can clearly see what the y-intercept is and the slope is. Okay, so just make sure you do that. And so I'm going to transform this equation now into the slope-intercept form. So let me write over here. So we have minus 5y is equal to negative 6x plus 15. Okay. All right, so I need y by itself, because according to the equation is y equals. I need y by itself. So I'm going to divide this by negative 5, this by negative 5, and this by negative 5. So that becomes 1. So I have y is equal to, okay, negative divided by negative is a positive. So 6 over 5 x, and then 15 divided by negative 5 is minus 3. Now I can see that my slope is positive, is 6 over 5, and my y-intercept is negative 3. So look at the equations, look at the graphs now. My slope is positive. Therefore, I can cancel A and B. Those are negative. So that leaves me C and D. Okay, then look at the y-intercept now. Which one has a y-intercept of negative 3? See that? So C is the answer. Again, another option you can do is, once you transform the equation into this format, you can graph it and see which one is the right graph. Okay, another way of doing it. All right, let's move on. I think this we did on the earlier slides. It asks which expression is equivalent, mean equal, the same, right? So this is exponential. Keyword is equivalent. Man, I just cannot spell this morning. I need some coffee. And then I can use a calculator. Okay, it's hard to explain here. I'll have to show you in class for this one. And so remember, for exponential, right? We have x to the 1 times y to the minus 6 raised to an exponent of power of 2. So remember, we have an exponent raised to a power. You just multiply the exponents, right? So that's going to give you now x squared y to the negative 12. Okay, that's h right there. All right. Again, this one was done earlier too. Again, what I want you guys to think of is, whenever you see a quadratic equation, two things will come to mind. You're going to graph it, one, and also, is this a perfect square trinomial? I look at the last term, is it 16? So that is 4. The first term is also perfect square. If I take the square root of that, that is 3x. All right. Let's do my test now. It's going to be 2 times 3x times 4. That gives me 24x. I get this 24. So yes, it is a perfect square triangle. It matches. So now all I'm going to do is 3x, the minus sign, minus 4 squared. And that's your answer, J. All right. And I think I explained this on the last one of the last slides. All right. I can eliminate G because there's no, all these terms are this positive. This as a negative term. So you cannot get a negative from this. So G is not going to be part of the answer. And so is H. H is not going to be part of the answer because they're both negative terms. They're both positive terms, right? And I have a negative right here. So this will never give me an answer like that. So now if I have to graph, all I'm going to graph is this in the calculator and then graph F and J and see which one matches it. Make sense? All right, good. So graph, I put graph right here. Little tricks you can use. All right, let's move on. Again, this one we did earlier too. Again, this is exponential. The key word is equivalent. Again, equal to, right? Equivalent. And again, use the same rules for exponential. We have x to the power of 22 times x to the 7 raised to the power of 3. So you know I'm going to multiply these two. That's going to give me now x 22 times x to the 21. Now I'm adding with exponents, right? So I'm just going to add, and that's going to give me 43. All right, so P is 43. And you just positive, you can go 4 here and 4 there. All right. Good. All right. Next one. Okay. Again, give a graph. Okay, it is linear. Again, so the first thing you want to look at is what is my slope? Remember, I told you before, if you have a linear function, look at the slope. Is it positive or negative? What is the y-intercept? Here, the y-intercept is -3, and the x-intercept is 4. Good. Now I look at the equations, they all have positives, they all have positive slope. So that's not going to help me. So now I've got to find the slope of the line. So I'm going to use rise over run. So I'm going to pick 2 points. I'm going to go with this one where it crosses the y-axis. And then I need to find a good point. Let's go with this one here. And to be honest with you too, I said the x-intercept is 4, right? It's probably not. I'm looking at the line. I don't think it crossed. The only thing with this graph, it's hard to tell, but it may not be 4 here. I don't think it quite crosses 4. All right, so let's do rise of run now. I'm going to find the slope. So rise of a run is 1, 2, 3, 4, 5. So 5, rise is 5. My run now is going to be 1, 2, 3, 4, 5, 6, 7. All right, and because I went to the right, all right, it's going to be a positive. You can tell the line, the slope is positive, the line is positive. So now which ones can I eliminate? Well, the slope is half of 7. So I can eliminate A and B because the slope is 7 over 5. Now I'm left with 2. Now, an easy way to do this now is to graph. You could graph C and D now in your calculator and see which one matches the graph, right? Or you could write the equation, right? So let's write the equation now. So option 2 now, I'm going to write the equation. So now I have my slope. My slope is, all right, I erased it. I need more space. My slope is 5 over 7. So I'm going to use the point slope method, which is y minus y1 is equal to m times x minus x1. So let's pick, I'm going to pick 2 points here. They use the point -7 and 2. You can tell. -7 and 2 is the point they used. Sorry. No, they, okay. Well, okay. I think what I'm trying to say is this: instead of writing the points, let's back up for a second. I'm making it hard. Look at these 2 points now. The two options. My points here from this equation, right? My points are going to be, remember, we're going to flip the signs when we write the points. It's a +7 here, so it's going to be a -7. Oops. And it's a +2 here, so it's going to be a -2. For this one now, it's a -7, so it's going to be a +7 right as a point and a +2. So which point is on the line now? Look at these 2 points and see which one's on the line. Well, let's see. -7, -2. Is that on the line? -7, -2 is right there. No, it's not on the line. The next one is 7 and 2. Yes, so that's on the line. Okay. So D is the answer. Again, you don't really have to write the equation. I think I was trying to make things a little bit more difficult right there. All right, so to recap, find a slope. Is the slope, is the line positive or negative? My y-intercept, I think is 4 for my x-intercept, right? Now, the slope, the lines are all positive. The slopes are all positive, so this is not going to help me right here. So my next option was to find the slope, which I did, 5/7. And when I did that, I realized, no, I can eliminate A and B. That leaves me 2 equations. Now, one, you could graph these 2 equations, see which one matches the line again, or you can see what point did they use to write this equation. This equation here, they use -7, -2, and this one they use 7, 2. And then you see which point is on the line. All right. Okay, let's move on. Okay, all right, now this is exponential, all right? Exponential, and the keyword is, again, best represents, right? And by now you should know what it means. Which one is the same or equals best, oh my, best represents, all right? Okay, so they want a domain. Remember, domain are x values, right? So in domain, we start on the left side where the graph starts at and where the graph ends. Well, the graph starts right here at -2. And if you notice now, all the x values for this graph keeps on going this way. So they are all greater than -2. Now, be careful. Now, a lot of kids, they just like, they pick this one. They're not being careful. Okay, they're being sloppy. All right. So make sure you pick the right one. It's X and not D, because domain are X values. All right. Can you graph this? Not really on the calculator. That's not going to help you. Now on this one, it's a little bit tricky. And you will probably see this on the STAAR test. They're like one of my favorite questions. Okay, the graph of quadratic function f was transformed. So we're talking about transformation, right? So keyword is transform. So start thinking about transformation now. It's transformed, and we say this is a quadratic, all right? And to create a new graph of f of g of x is equal to f of x plus 2. Let's look, it's confusing here, right? Well, it's very simple. I'm going to show you this. Now, the parent function f was transformed. What is the parent function? By now, you should know that the parent function is f of x is equal to x squared. Okay. And for the graph, it just looks like this. The parent graph, it just looks like that. Now, it was transformed to f of x plus 2 minus 5. This kind of is confusing, but look at this now, right? It's x, look at the parentheses, x plus 2 and a minus 5 on the outside. So just look at it now. In the parentheses, if it's x plus 2, what's going on with this transformation? Which way is the graph going? by now you should know that x plus 2 means the graph shifts to the left, all right? And then minus 5, it went down 5 units. So which graph now shift left 2 and down 5? Well, it can't be that. That went up, okay? It can't be this because it shifted to the right and went up. I'm looking for down. So look at these two now. Well, it shifted to the left 2. So this one shift 1, 2, right? Shift 1, 2, and down. 1, 2, 3, 4, 5. This one shift to the right, so it can't be this one. It shift 1, 2 to the right. 1, 2, 1, 2 to the right. All right, so the answer is H. All right. Okay. Let's move on to, okay, an exponential. Okay, this is an exponential. Keywords best represents. I'm going to stop writing this. That's keyword right there. Okay, several ways you can do this, guys. And again, I want you to look at exponential. Look at the graph. Just like in linear graphs, you want to find, you want to know if the slope is positive or negative. Is it, what is the x-intercept, y-intercept? Whenever they give you exponential, key things I want you to look at is this. What is the y-intercept? Okay. Is it increasing or decreasing? Okay, that's a big difference. If it's increasing, you know then that, remember, the function for exponential is f of x is equal to a times b to the x. If it's increasing, you know b, the base is going to be greater than 1, right? The factor is going to be greater than 1. If it's decreasing, you know the factor b is going to be less than 1. So that's very important. So you're going to find a y-intercept. Now look at this graph now. I remember a is your y-intercept. A is your y-intercept or the initial value. I'll put IV for initial value. So look at the graph now. We see that the y-intercept is 6. So my A is 6. My A is 6. And is the graph increasing or decreasing? Is the graph increasing or decreasing? As you can see, if I look at the graph, if I go from right to left, right, you can see that the graph is going down. So that's how you read the graph. As you go from right to left, the graph is going down. So yes, it is decreasing. So therefore, my base has to be less than 1. So let's look at it now. So, this is not the formula. This is not equation for exponential. There's no minus in there. So we can eliminate C and D, all right? It is A times B. It's not 6 times. It's not A minus. And so we have A and B now. They both have 6, all right? And then, so which one has a base less than 1 because it's decreasing? Answer is A. Okay, or you can graph them. Another option, if you're still confusing this, you can graph them, right? And see which one is the right graph. Hopefully you realize this is not exponential, the equation for exponential. So the only two you'll be graphing is A and B. All right, another way, so you can graph. Let me put graph right here. All right, moving on. Okay, what we have here is the quadratic. Again, when we see quadratic, think graph, think graph. And then keywords best represent. Again, I'm gonna start right, best represented. So how are we gonna approach this now? Well, I think for you guys, I'm trying to see how to, if I were you guys, those are my X and Y intercept. Okay. So if you're not sure on this one, you're like, oh, where do I go? Just go ahead and graph the 4 options and see which one matches this. Or if you recognize this now, To find the x and y intercept, right, we set the equation equal to 0, right? So we set 0 is equal to x squared minus 3x minus 9 and factor. I think that's time. I can see that if I set these to 0, I'm going to have 0 is equal to x squared minus 6x. All right. Now, if I know now, I see this, if the GCF right here is, I'm going to put a 0 on my right side, right? Equals 0, doesn't matter. I see x is my GCF. So if I factor out x now, my GCF is x. So if I factor out x now, divide this by x, divide by that x, I'm going to get x minus 6. All right. Because the x cancel that gives me 6. X squared divided by x1 is just x. So my factors now are x times x minus 6, which equal to 0. And I can see then that set both factors to 0. I'm going to have x equals 0 as one factor, and the other one, x minus 6 equals 0 as other factor. And add 6 on both sides, that gives me x equals 6. So 0 and 6 are my x-intercept, which matches this. However, if you don't see that, all right, the best option here is to graph the 4 options and see one matches. I'm not going to recommend it to you to factor all of these and see which one is it. All right. So graph. Simple one here is graph this one and see one matches. All right. Okay. Looks very complicated here, right? But I tell you, it's pretty easy. Again, remember what I said before? Look at your equations. All right. Some of us that can find the x and y intercept from this, from standard form, probably can't handle this. But just go ahead and transform the equation into y equals mx plus b, and then you can see what the slope is and what the y-intercept is. So let's do that. That's probably the easier way to go with this. So the first equation is, let me go over here. The first equation, this is linear. I didn't fill it in. Keywords, again, best represents. And calculate, yes, we're going to graph. I'm going to show you on what you can do that. So here we go now. I'm going to transform the first equation into y equals mx plus b. Again. So we have, I need some space. All right. I'm going to have 8x minus 4y is equal to negative 16. All right. All right, guys. So remember, I want y by itself. By now, if you're not good at this, you got to practice this stuff. I want y by itself. So here I have 8x. I'm going to minus 8x here and minus 8x on that side. So now that becomes 0. So I'm left with now minus 4y is equal to, when I add these two, right? Remember, you're not going to add 16, negative 16, negative 18. I'm just going to add negative 8x and minus 16 combined together. That's what I get. Now I need to divide. This is a negative 4 times y. So I'm going to divide by negative 4, divide by negative 4, divide by negative 4. That becomes 1. So I'm left with now y is equal to 8 divided by 4 is 2. 2x and then plus 4. So that's my first equation, right? I'm going to write it here. Y is equal to 2x plus 4. Let's do the other one now. I'm going to erase this and get some more space. The other one is, is 3x plus 15y is equal to minus 6. Hopefully, you know to do this one from the first one I did. You can do this one, okay? If you need to pause it, go ahead and pause and try. All right, I have a 3x here, so I'm going to minus 3x here, minus 3x there. That goes away, it becomes 0. Now I'm left with 15y is equal to minus 3x minus 6. Okay, divide by 15 now on both sides. Divide by 15, divide by 15, divide by 15. Okay, That goes away. That becomes 1. So y is equal to now 3 divided by 15 is 1/5, right? 1/5. Negative 1/5x. And then this gives me negative 3/5. Yeah, negative 3/5. So my other equation now is y is equal to minus 1/5x minus 3/5. All right. Once you've done this now, you can graph both equations and see which one it matches in the calculator. Or let me erase this now. Okay. We know one equation has a positive slope and one has a negative slope. Okay, so let's look at now. One is a positive, one's a negative. Okay, so they both have positive, negative. They both have positive, negative, positive, negative. Okay, good. Now let's see. Now one of them has y-intercept of 4, and then the other one is okay minus 3/5. If you write that, that's probably 5. That's 0.6, right? Yeah. If you convert this to decimal, right, this is minus 0.6. Okay, so let's see which one is that one. A positive, the y-intercept is positive 4. So this one has a positive 4 y-intercept, and this one has a y-intercept of 4 and a positive slope. Okay, so which one has a y-intercept of 4 and a positive slope? That's gonna work. Yep. Right. So this is the only one now. So the y it's a positive slope and the y-intercept is 4. Let's look at the other one. It's the only one that has that one. Yep. And the other one is negative slope, right? And the y-intercept is negative 0.6. Negative 0.6 is right. Yeah. 0.6 and negative slope. As you can see now, B is the answer. If you're confused on what I did a while ago, just graph both equations and see which one is it. All right. Again, so let me go back. I think I need to go back and kind of explain what I did a while ago. All right. One equation here as the y-intercept is 4 and the slope is positive. The only one here, the graph, that has a y-intercept of 4 and a positive slope is this graph right here. And this is positive 4 and a positive slope. And the other equation is a negative slope, right? And the y-intercept is negative 0.6. Again, this is the only one that has that. A negative slope going down and the y-intercept is negative 0.6. All right, just want to make sure I clarify that. All right, let's move on. This is taking a little bit longer than I expected. Okay, again, quadratic function. Let's see. And again, the key word is best. Okay, best supported, meaning that you're gonna figure out, are all 3 answers correct? Is it just 1, 2? You gotta figure out which one's correct. So let's look at it now. The x-intercept is -3, 0. The x-intercept, yes, that is correct. So we know 1 is correct, right? That's the x-intercept. The coordinates of the y-intercept are 0, 9. Yes, that is correct. 0, 9. So we know 2 is correct. And the axis of symmetry is x equals -3. The axis of symmetry, remember the line that splits the graph, x equals, yes. So 3 is correct. So all 3, 1 to J is correct. Okay. Can you use a calculator in this one? Yes, there's a way you can do that, but it's very time consuming. All right. All right, let's move on to, move on to the next one. Okay, how many do I have left? Oh, this is the last one. Okay, I gotta get ready for class. Okay, let's see. You have a linear, okay, linear, and it wants to, what is the rate of change of y with respect to x for this function. Okay, don't let this confuse you. Of y with respect to x. All it's asking for is the slope. Rate of change is a slope, all right? And so, and look at that, they give you 2 points you can use. All you gotta do now is use the formula and plug in the numbers. And so we have m is equal to y2 minus y1 over x2 minus x1, all right? And so if I say this is my x2, that's my y2, my x1, my y1. So let's plug in the numbers now. Okay, linear. Y2 is 2, good. Minus my y1 is 3.6 over my x2 is 5 minus my x1 is minus 3. So this is going to give you a positive. All right, positive. So now 2 minus 3.6 is, and you can use a calculator, that's negative 1.6 over 5 and 3 is 8. And I think it's going to give you 0.2, negative 0.2. If I do my math correctly. And so again, to bubble, negative, and then we're going to use the decimal, the point, 0.2, right? Or some you may go other way around. You may go to the end. Then I just do this instead of putting it right here. Make sure you have negative, and then go all the way down to 0.2. All right, 0.2. Is that, did I mess up the first one? Let me go back and see what I did the first one. Okay. Oh, no. I did this wrong. Point. The 2 should be right here. I thought I did something wrong here. 0.2. Yeah, 0.2. Or the other way. All right. I never had bubble charts when I was a kid. That always confused me. All right, I think that's it, guys. All right, so that's a review for today's version of the STAAR review. Okay.